Hello everyone. So in the last session we studied about centrifugal pump and its working. So I actually forgot to explain the function of this footwall. So this footwall acts as a non-return wall. It will allow the flow of water only in this direction. The return flow will be prevented. So that is the function of a footwall. So with respect to this centrifugal pump, there are two important concepts. Those are cavitation and priming. So let us see what is cavitation and what is priming one by one. So we'll start with the cavitation. Phenomenon of formation of vapor bubbles and its subsequent collapse in the low pressure region around the impeller. So that is cavitation. That means, see here, water will be there in the sump, that will be sucked to the casing, to the impeller region, right? So in case if there is any air gap or a vacuum in the pipe, so what happens, there is a chances of formation of water bubbles, okay? And in the variations of pressure, if the bubble collapses, means it will cause damage to this particular impeller and its blades. So that particular phenomena is in general called as cavitation. So it causes damage to the impeller. Of course, it can be identified by a clear audible noise and vibrations. So it is the outcome of the cavitation. Okay, so there are some measures to avoid cavitation as well. So let us see one by one. Lower the temperature of water. So if you use low temperature water, we can avoid cavitation. By the time the chances of formation of air bubbles will be low. Okay. Second, ensure suitable liquid level in the suction side. So we should have sufficient water in the suction tank as well in the suction pipe. So if there is shortage of water, chances of air accumulation is there, and so that air bubbles takes place and it causes damage to the impeller. So we should ensure the suitable liquid level in the suction side. Okay. Third, by suitable impeller design. So we should work on the impeller design so that air bubble should not cause damage to the impeller. Okay, so this is one of the criteria. Another, by maintaining suitable fluid pressure. So we have to work on fluid pressure so that cavitation can be avoided. And the last one is checking for the blockages in the pipe. So if there is any blockage in the pipe, chances of cavitation is more. So we should regularly avoid this blockage in the pipes. This is about cavitation. Coming to the priming. So let us see what is this priming. It's a process of filling liquid into the casing, suction pipe and delivery pipe up to delivery valve before starting the pump. See here, I'll explain. Before starting this pump, we have to manually fill the water to this suction pipe, to this casing as well to this delivery pipe up to this delivery valve. Okay, we have to manually fill the water till here, so that we can avoid the air trapping. So that is the main intention of this priming. See here, it is required to remove the air trapped in the pump. Okay, that is one reason, and the other is to reduce the risk of pump damage during the startup. So that is why priming is required. So this is about cavitation and priming. In our textbook, a brief description is there. You can go through that. Just for the understanding sake, I have explained cavitation and priming. So in today's session, we shall see what is a reciprocating pump. So this completes the hydraulic pumps section. Okay. So coming to the construction of reciprocating pump, it has got a piston, cylinder, delivery valve, suction valve, delivery pipe, suction pipe and discharge. And it has got connecting rod, crank, etc. Okay, so coming to the operation of reciprocating pump, it is quite simple. It operates on the principle of reciprocating motion of a piston. Okay, so now what happens? See here, there is a shaft and there is a crank and connecting rod. When the motor is switched on, the shaft will be rotated. Okay, so the rotary motion of the shaft will be converted into reciprocating motion of the piston by means of this connecting rod. So this you know in IC engine mechanism, the same mechanism will work here. So once the shaft rotates, the piston reciprocates, right? So now I have marked it here A, B, C, D, right? So now what happens in the beginning is the shaft rotates from A to C. Shaft rotates from A to C. What happens by the time the piston will move to this side now? When the shaft rotates from A to C, the piston will move to this side. That movement of piston towards right will cause what? Will cause some vacuum in this cylinder region. So as a result of which there will be a creation of low pressure area in this particular portion, and here the pressure of the water will be more. So the usual tendency of water is to flow from high pressure region to low pressure region. So as a result of which all the water from this sump will be transferred to this cylinder because of pressure difference. So because of the pressure, even this suction valve opens automatically and all the water reaches cylinder. So now the shaft is in position C. So what happens now? The shaft will move back to C to A now. C to A. So once the shaft moves from C to A, the piston movement will be from the right to left. So what happens? It will create pressure on the already collected liquid in the cylinder portion. So what happens? Anyhow the suction valve will be closed. So it will in turn exerts pressure on delivery valve, and all the water will be go through the delivery valve and it will be discharged. So this is how a reciprocating pump works. And again the cycle repeats. Again once the shaft will be in A, again it will move to C, again partial vacuum creates, again the water from the sump move to the cylinder region, and again from C the shaft will move to A. So again it will insert pressure on the liquid and it will move to delivery valve and it will be discharged. So this is the mechanism of reciprocating pump. Hope you understand this. Thank you.